Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have c divided by c plus c plus c is equals to c, and we solve this problem for all the values of c. So here we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. Now we move towards the solution of this problem from first method. So in the first method, you see here, these are the three like terms are added by each other. So it will be written as c divided by c plus c plus c becomes 3 times of c, and this whole equation is equals to 0. And now in the next step, we move this 3c from left hand side to the right hand side, and it will becomes c is equals to, this is 3c divided by here. When we move it into the right hand side, it is multiplied by this c, and it will becomes 3c multiplied by c. And further in the next step, we have c is equals to 3c multiplied by c becomes 3c square. And in the next step, we have here we move the c from left hand side to the right hand side, and it will becomes 3c square. This is positive c. When we move it into the right hand side, it will becomes negative c, and this whole equation is equals to 0. And now in the next step, we need more simplifications here, and you see that both of these two terms involve c, so that we take common c from here, and when we take common c, we get the remaining values are 3c minus 1, and this whole equation is equals to 0. And now in the next step, we need to divide this equation into the two cases. The first case is we write c equals to 0, and the second case is we write 3c minus 1 equals to 0. So this is the first root of the given equation. And now here in the next step, we need to move this minus 1 to the right hand side for the other roots of this equation. So we get 3c equals to, this is minus 1. When we move it into the right hand side, it will becomes plus 1. And further we divide both of the sides by 3. So when we divide both of the sides by 3, it will becomes here, this 3 and 3 are gone, and we get here c is equals to 1 over 3. This is the value of c. This is the other values of c. Okay, so here you see that in the first method we get these are the two roots of the given equation, and in the next step we need to verify that is these roots with the solution or is these roots with the extraneous roots. So for verification of these roots, we need to copy down given question statement here, and it is c divided by c plus c plus c is equals to c. And now here in this side we will be verify c is equals to 0, and in this side we will be verify c is equals to 1 over 3. So here first we verify c is equals to 0, and when we substitute c equals to 0 into the both of the sides of given equation, it will be written as 0 divided by 0 plus 0 plus 0 equals to 0. So further in the next step, we have here we need to simplify the terms, and we get in the left hand side becomes 0 over 0 form equals to 0. And you clearly see here our 0 over 0 form is becomes here indeterminate form. Okay, so if this is indeterminate form, or in other words, we just say that it is undefined. If our left hand side is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes about that the value c equals to 0 is not satisfied our given question statement. So we call that c equals to 0 be the extraneous root of the given equation. Okay, so this is the extraneous root because it does not satisfy our given question statement, and here we need to verify second value of c. So when you substitute c equals to 1 over 3 on both of the sides, it will be written as 1 over 3 divided by 1 over 3 plus 1 over 3 plus 1 over 3 is equals to 1 over 3. So here you see that we get 1 over 3 divided by, this is 1 over 3 is added by 3 times, it will be written as 3 times of 1 over 3 is equals to 1 over 3. And now again you see here this 3 and this 3 are gone, and we get here only 1 here, and we obtain this is 1 over 3 is equals to 1 over 3. So this shows that both of the sides are equal, and if both of the sides are equal, this means that the value of c is equals to 1 over 3 is not satisfied our given question statement. Is satisfied our given question statement. Okay, so finally we have the solution set of this question is c equals to 1 over 3. So this is the only one solution which we get here in the first method. And now we again solve this problem for second method. So for second method, we need to copy down given question statement here. So that our given question statement is c divided by c plus c plus c is equals to c. This is our given question statement. And in the second method, we again first simplify the terms, and in the denominator you see here c is added by 3 times, and it will be written as 3 times of c is equals to c. And now you see here this c and this c are gone, and we get here 1 divided by 3 is equals to c. So you see here we get only one value of c, that is 1 over 3. And in the first method we already verified that this value of c be the solution, or this value of c satisfied our given question statement. So here we don't need to again verify these values. So finally we can conclude about that the solution set of this problem is c equals to 1 over 3. So this is the only one solution which we get here in the second method, but in the second method we cannot get any other extraneous root. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.